So again, we have our square base pyramid here with all the same dimensions as before, but this time we're going to be using trigonometry to find out an angle. So if we take our triangle out here, we're interested in the angle that the length of one of the edges of the pyramid makes with the square-based plane on the bottom. So it's difficult to see from the outside, but if we open up, we can see that what that is saying is that it is the angle A in our right angle triangle, because the line AV, if I put this together it'll be a bit easier to see. Yep. So the line AV, remember that is the edge of our square-based pyramid, where the faces, the triangular faces meet up. And so we want to find out the angle from that edge to the plane on the bottom, so the flat part of the base. And that angle is the angle A of this right angle triangle. So if we take the triangle out, lay it flat, a bit easier to see. And so then we're using trigonometry. So we have to think about the lengths that we got before. So we had for AO is equaling the square root of 8 centimeters. We have the height here is 3 centimeters, and we find out the AV as being square root of 17 centimeters. And then if we label it the usual way, so the hypotenuse is the longest side opposite to the right angle triangle. So this is our H. The angle that we're interested in is A, so the adjacent side is the square root of 8. That's our A, and then the opposite length to the angle that we're interested in is our O. That's our opposite. So then we have a choice of which trigonometric functions we want to use. So I will start off with so sine of A, our angle that we don't know, is equal to the opposite divided by the hypotenuse, which is equal, in this case, to 3 divided by the square root of 17. And so to find out what A on its own is equal to, I use the inverse function of sine on that fraction, 3 over square root of 17. And if I have it in my calculator, so shift sine, make sure I've got the inverse function, do my fraction sign, and put 3 on the top, square root of 17, bottom, close my brackets, and then I get 46.7 degrees to 1 decimal place. And to show you could do it also with sine, if we, or sorry, with another one, not sine, so I just did it with sine, but we could also use cos in this case, because we know all 3 sides. If I did cos of A equaling the adjacent over the hypotenuse, that would this then be equal to the square root of 8 over the square root of 17. And then if I want to find out A on its own, do the inverse function of cos to that fraction. I find out then, so inverse cos fraction square root 8 over square root 17. And again, that's equal to 46.7 degrees Celsius. Sorry, just degrees, not degrees Celsius. 46.7 degrees for the angle. And again, if we want to find out V, you could also use trigonometry, but we could also use the fact that the angles inside a triangle add up to 180 degrees. So if we know that, then the angle A in degrees plus V in degrees plus 90 degrees is equal to 180 degrees. So in this case then that would be 90 minus our 46.7, so roughly V's angle is about 43.3 degrees. And you can check yourself using tan that you could find out this angle, or you could find out the angle V from the top, which would be the angle that would be made from the side length of the pyramid, so one of the side lengths, to the vertical if you had a straight line going through the midpoint to the peak.